Hi guys, welcome back to Advent of Code, day 6. Let's see. So, today we will get this input over here, and this is called a map. Now, on this map we have a guard, which is this symbol over here, and this symbol represents a direction, meaning the guard moves up, okay? Now, these symbols over here represent obstacles. Alright, so if the guard goes up and he would hit an obstacle, he would instead go right. Okay, so he would hit an obstacle and he would go right. Okay, until he finds another obstacle and then he moves right from its position. Right, so it goes down until another obstacle and then it will do that. I have over here drawn this, so we would go up, then here is an obstacle, so we go right, obstacle, we go right, 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 and right. Over here we are at the end. Okay, if we are like this, we can't go on the right side because there is an obstacle. So this will be the end position. Now we have to count all the cells the guard has traversed. All right, and in this example it would be 41. So I want to show you the logic of the code first, because this time this is a little bit bigger, and I have structured it in a way with structs and methods, and I show you so we'll understand. So we have the struct lab, and lab represents this whole thing over here. So we have the grid. This is this in a vec of u8. So basically a vec of a vec of a char, but casted into a byte, right? Just for performance. And then we have a guard. The guard, as I've said, represents this over here. And the guard is a struct with a position and a direction. Okay. Now, the position, sorry, this should be position. Now the position is just a struct with two i32 values, and direction is just an enum with up, down, right, left, so we know which direction. I've actually wrote here pause, right? And with these types we can create up the logic of these things. So the first quiz is actually pretty simple, and the second one was a pain in the ass. So the logic is very simple in the first one, because we are at the start position and we check just the next position of the direction, right? So we check, is this an obstacle or not? If it is not, then we will just put the current position over here, right? And we do that like we did before with offsets. So this enum direction over here provides offsets, right? So if we are at start 6-4, right? So we start at this position 6-4, and the direction is up, right? So if we want to go upwards, the direction method offset will give us an offset of -1 and 0, right? So the row is -1 and we stay in the same column, right? So if we have 6-4, we add -1, 0, and this will then be 5-4, right? So this will be the next position. So this will be the next position, 5-4 over here. And then when we are here, we are at position 1-4. We set the direction to right, okay? And right will have another offset. It will be 0-1, okay? We stay in the same row, but we go 1 to the right. So we add this offset, 0 1, and we will get 1 5. Okay, row 1, column 5. We are like this in this direction because we have the direction right, and so on. Okay, it's not that complicated. So I've already copied the test input, and let's see. So first of all, we want to create a struct, right, where we will store all of these things. We will parse. So struct lab, we have the grid, a back of U8, and we have guard, which is of type guard. Okay, and let's create guard. As I said, guard will have a position and a direction. Okay, and position is just a tuple structure with two I32 values, and we need an offset for this, like that. And then we have the enum direction, which will be up, down, right, left. Okay, now first thing is we want to actually parse the input, right? So we do that by creating by implementing the from trait. So from string slice, and the input is of type string slice. We get back self, and let's first do the grid. So grid is a back of U8. Take the input, we iterate over the lines, we map each line. In each line we iterate over bytes. I take bytes, but you can also take characters. It's not that much of a difference. So then collect, and we collect the outer vector 2, right? So we have a back of U8. Then for the guard we need also the position, right? So in the grid we iterate, we enumerate, so we get the index, and then we do a find map. So find map is really cool because we can apply a function to the elements of an iterator, right? So we parse and then we search at the same time. So we parse this and we find the first one that will be parsed, right? So the first number. So find map, we have X and row, so the index and the value on each grid. And then we iterate over the row, and we want to find the position of the character which matches this character, right? Like that, and then we map Y, so we get the Y position, and we have X as I32 and Y as I32, right? Then we unwrap or default. Okay, now we have to implement default for position, and we can just derive that like this, right? And then we have the position of the guard, right? So we need this position over here, and that's all. So we return self, the grid, and guard will be guard with the position, and direction will start with up, right? Like that. Okay, all right, then let's see. All right, so we need the count variable, so we can return here count, and lab from, so we take the test input, we call the walk method, and the walk method will return a hash set, so we will just get the length and parse it as u32. Okay, now we have to implement this walk method, so let's do that. And we implement that for lab, right? So fn walk, we take a mutable reference to self, and we return a hash set which holds positions, right? Basically the visited positions. Hash set new, we initiate a hash set, and then over here we can just loop, right? So as I've said, we want to have the next position, so self.guard.position, right? So in the first iteration this will just be the starter position, and then we want to add the offset. Okay, and we didn't implement the offset method, so let's do that in the direction type. As you can see, this is very clean because we have the logic splitted up in the various types, right? So offset belongs to direction, right? So we put it over here. Method offset, we take self and we return an offset, right? An offset is basically just like a position, but I thought I would split it just to make it a little bit clearer, right? So we match self, and if it is up, then we return offset -1 0, right? So row -1, and we stay in the same column. Down will be off 1 0, right will be 0 1, and left will be 0 -1. Okay, and that's it. And now we have another problem, right? Cannot add offset to position, okay, because these are different types. So what we can do is we implement add trait for position, okay, and we implement the add trait for position with the off type, with the offset type. So type output will be self, right? And let's add the signature, so we get an offset, right? We get an offset, and I destructure it right in the function signature or in the method signature, right? But you can also destructure it inside, it doesn't matter. So we have delta x and delta y, and then we just return self.0 plus dx, self.1 plus dy, okay? Like this. So we have self, which is a position, we have the offset, which is the right side of the plus symbol, right? And then we just take from position the first element in the tuple, and we add it with the first element of this offset, right? With this. And the second one too, right? And then we have a new position. All right, so we implemented that. And then all we have to do is we match self.get next, okay? So we have over here the next position, and now we have to implement this get method. Let me do that really quick. So fn get self. I again destructure right in the signature, and we return an option. So self.grid get x as usize and get y as usize, and we do copy it, right? Because u8 implements the copy trait. Okay, and because we return an option, we can use the question mark operator, which is really neat. All right, and then we check if we get back this symbol over here. That means we have an obstacle, right? So we have to change the direction. So self.guard direction turn, right? This is another method we have to implement. And if we have any other symbol besides that, then we know it's a point, right? It's a dot. So self.guard position will be next, right? Because that means it's a valid position. If we get back none, we break out of this loop, because then we have reached the end, right? If we don't get back any new symbol from the grid, we know we have reached the boundary, right? And we break. And then all we do is we return visited. So we return the hash set. So we return the hash set with all the positions we visited. So hash set is a very useful type in this case, because every value in it has to be unique, and I'll show you why. So we start over here, and when we traverse the grid, sometimes we cross, right? But that's why we are storing all the positions we visited, right? So we don't have duplications, because we don't want to count this 2 times, right? We visited this point, so when we have it in here, then we don't count it the second time. That's why. All right, and as you can see, we have to implement the turn method, and turn is also in the direction struct, right? So turn, again, we take self, and this simply will turn right. So if we have direction up, we will return direction right. Right will be down, down will be left, and left will be up, right? It's basically a 90-degree turn. Excuse me, of course, we have to match self first, so we know what we are matching here, like this, okay? And we do that if we find an obstacle, right? So we update this direction in the guard struct, okay? And let's implement for this over here the copy trait tool and clone. All right, and for position, let's do it too. Copy and clone, like that. Okay, that's basically it. What we forgot is we have to insert into the hash set the position, right? So the position we are in, and to do that we actually have to also derive some more. So hash EQ hash and partial EQ. Okay, because that is required from the hash set type. Okay, so we add the offset, we insert, let me do that first, because we insert and then we care for next, right? We insert always the current position, okay? And yeah, that will then go on until we don't get any new value from the grid, meaning we are reaching the end, okay? And in the end, we just return this hash set, so we can over here take the length of this hash set and that is the number of positions we traversed. Cargosolve 6 release. This is 41, and that is correct. Let's take the real input. Okay, let's submit. And that's the right answer. Okay, part 2. And I tell you right now, part 2 is a lot harder than part 1. So what it wants us to do over here is, we have the same test input, right? Let me actually copy that. Okay, so we have the same test input. Now what it wants us to do is, we have to place one obstacle in the map, right? And we have to place this obstacle in a way that when the guard traverses the grid, he will be in a loop, right? So let me show you that over here. So let's say we are putting an obstacle here, okay? Now again, it's the same logic. We go upside, then we turn direction, we go here, then we turn again right, like that. But now here is an obstacle, right? So what are we doing? We turn right, okay? Now, as you can see, this can go on and on forever, basically an infinite loop, okay? And we have to find out how many obstacles we can place in a way that this guard will be jailed in a loop, in an infinite loop. Okay, so in the example it would be 6 different positions. Okay, and so the logic over here is not quite so different. Before that we had a hash set, right, with positions. Okay, and this was enough, right? Because we just wanted to not duplicate any positions. But now we will need a hash set with positions and directions, okay? Because now we also have to check. Let me do this example once more. We have here an obstacle, right? So we follow the same logic. We go up, right, like this. But now, as you can see, when we reach this point here, we turn up, okay? So we are again at 6, 4, and the direction is up, right? And we were there before. That means we are in a loop, right? So basically we just have to check where at any position on this grid did we already have a point traversed on this position with this direction. Okay, so we can't have this 2 times a duplicate. We can't have this, otherwise we would be in a loop. That's basically it. But to implement that, it took me a long time to figure out, to be honest. So what we can do, let's take the lab. So we took this and we have to store the original point, okay? So the original point was, we have a guard with position 6, 4 and direction up, right? This is the origin, okay? And that is because we have, when we parse it, we get this back, right? The first thing, we initiate this structure, right? So that's the origin point. Then let's have the hash set for visited, right? So we call the same method we did in part 1, walk, right? Walk, we just return the hash set with all the positions we visited. Because now what we can do is we take visited and we iterate, right? So let me actually print that out first. Visited. This doesn't implement debug. Okay. Debug. Guard. Okay, let's also derive here a copy and clone like this. Okay, now so let me see what this will output. As you can see, we get here the hash set for all the positions we traversed. Okay, so that's what we'll get back when we do this walk method. Okay, because what we then can do is we take visited, the hash set, we iterate over it, we filter, and we now basically in this visited hash set, what we are doing, so we traversed this way, right? So we get back a hash set with all the positions over here, right? Now we want to actually place an obstacle in every single position we traversed, right? So for example, if we go over here, we place an obstacle and we see if it loops. Then we place here an obstacle, then over here, then over here, then over here, right? Then over here and over here and over here and here and so on, right? Until we find a place, let's say over here, where we will loop. Okay? So obstacle and then lab looping. This will be another method we will implement. We pass the origin point and position we will place the obstacle, and then we just do count as U32. Okay, and then in the end we can return some count. Okay, as you can see, we have to implement this method. So let's do that. Looping and origin and obstacle. Okay, so first mute self. Origin is of type guard and obstacle is of type position, right? And then we return a boolean because the filter method over here expects a boolean. Okay, so let's again create a hash set visited. So first of all, every time we are calling here this looping function, we have to reset the guard position and direction to the origin. Okay, and then we try and set an obstacle. So at this position over here, this could be any position from the hash set visited we walked over here, right? Any position we walked over, and we put this symbol, an O, capital O. Okay, now we have to implement the set method. Itself, we take a position, again destructuring it, and a new value, U8. So if let some cell Then self.grid, get mute, we take x as usize, and then we have the row. So in the row we get y as usize, like this. Then we just access the cell and put the new value inside, right? Like that. So basically we now placed an obstacle, and then let's start again the loop. So first of all, we try to insert self-guard position and self-guard direction, and if this insert method in the hash set, right, returns a boolean. So if we insert 2, for example, it will return true, but if we try to insert it another time, it will return false, because again a hash set has only unique values. So if this returns false, right, then we break this loop and we return true. Okay, then let's take the next position. So the guard position plus the offset, and then we match the get, so basically the next value, right, we get, and we do basically the same as before. So if we match an obstacle, and this time it should also be an O, right, the obstacle we have placed. So if we match any of them, then we just turn the direction 90 degrees. If we match any other symbol, which basically are only points, right, there are either this or this, there is nothing else. We can't match this because this is actually the position we are at the moment, but we are here matching the next position, so it's not possible to match the guard. So if we match a dot, then we just update the guard position to next, otherwise we break to return false, right? And let's store that in a variable, looping, and then after each loop we have to reset the obstacle, right? And then we just return looping. And that's basically it. Here hash is not okay. Or here we also have to implement. Let me take this. No default. Okay. Right. So in the end we return a boolean. If we tried to insert another position and direction, right, the hash set I've showed you over here, position, direction, if we match, if we try to insert another time, then we know we are in a loop, so we break out immediately and returning true. Okay, and the other things are basically the same. So if we don't match anything, then that means we are at the end of the path, and we break and return false because we didn't encounter any loop. And then we just reset the obstacle, and over here we have the count, and we just return the count. So let me actually modify that a little bit, so some we can return it like that. So let's see. Okay, 1.9 seconds. It's not the most efficient algorithm, but it will do. Okay. And yeah, let me see. Did we actually, okay, we took the real input. Let's see, test. It should be 6, right? 6. 6. Okay. Cargo solve. Submit part 2. Okay. Alright. I have to take the real input. Again, I think this happens to me every day. And this should actually work. Of course, now it's taking a little bit longer because it has to traverse a lot more, right? So this is the actual input. Okay, we have to wait. So. And that's the right answer. So, see you next time. Thanks for watching.